Nakapagawa daw manual computation ito, sabi ni engineer. Salamat. Neng, ito pa daw, oh. Diyos ko po, kailangan ko lang tapusin to. Ano to?
Katulad ka ba ni engineer na may sandamakmak na pending assignments? Say no more because with QuantifyIt, you can do it. QuantifyIt is a calculator program which combines several engineering calculations such as material selection, structural analysis, material testing, and cost analysis in one place. So why bother switching apps or sites when you can have it all? With QuantifyIt, you can have less hassle with more hustle. So now let's give you a quick guide on how you can use our program.
Good day everyone, my name is Spinas from LRG and I'm a member of this project. I am here to present to you the first part of our code. So what we have here, first off, from line 2 to line 6, we can see is what we call materials dictionary. With the name materials, under it are concrete, steel, and woods with its properties. We define a nested dictionary with each material like we had here. This maps to another dictionary containing its physical properties. These structures enable efficient lookup and modification by key and keeps the data organized by material and attributes. Next line, from line 8 to line 13. And mainly highlighting line 9 and line 13. This is what we call utility function. This helper function abstract by repeated tasks of printing a separator line. Like we see here, we printed line or dashes with iterations of 60. This improves code readability and maintainability. It will print boundaries with these results. Next line, with a comment of list available materials. With line 16 to 21, we can see is presentation function. This function iterates over each materials and displays its compressive strength, providing the user a quick visual comparison before making a selection or decision. Next, what we have here is a quotation of available materials with also iteration of 60 dashes. Number 1 for concrete, number 2 for steel, number 3 for wood. Here, we enumerate through the material keys to display them a numbered list. This makes the UI intuitive and emphasizes clarity and user choices. Next, with a comment of user selects a material from line 25 to line 36, with also if-else conditions or functions or command. Where we can call it as input handling. This function safely accepts user input and normalizes it using. We also use here that lower, which is will print a lower cases in their selections or in their answers rather. This make input case insensitive, our code. It also validates the input against the dictionary keys, returning none if the material isn't found, like we had here. Else, we print material not found with the command of return, which let us reprompt the user in the main loop. Next part. We have here comment show chosen material from line 39 to line 43. What we have here is what we call displaying material info or information. We isolate all outputs, display into a dedicated function for consistency. This improves code modularity, making the formatting logic easy to adjust later without touching the core program flow. With also command of that format, so we have uniformity. For strength, we will print name strength, density with name density, durability name durability, cost per unit with peso sign as name and cost. Also with iteration of lines of 60. Next, with a comment of let user edit properties. from line 47 to line 55. This part is what we call editing properties. Yes, our code will also serve not just by computing cost, but also you can edit your answers or selections or your answers as a user. So, this function gives us users the ability to modify selected properties. We include error handling using try or except commands to prevent crashes from invalid input, like, typing a word instead of a number. Optional updates are supported by checking whether the input is empty. Like we have here quoted as, do you want to edit material properties? Yes or no, with that lower command. And if yes, we had here the selections with also iteration of dashes of 60. And last, for our first part, with comment of show updated info. Basically, this part will just print or show the summary of all the outcomes with strength, density, and cost per unit, and being bounded by the dashes of iteration of 60. So, what is our program nga ba? This function orchestrates the entire flow. It shows strength comparison, prompts the user to select an optionally edit and material, displays both original and potentially update material information, and also uses a loop to validate user input and encapsulates logic and helper function for clarity rather. So what our code strength? So for me, it is modularity because each function does one thing well, following clean coding principles. Next is user feedback. Error messages guide users rather than, letting the program crash. And then third is maintainability. If new materials or properties are added, changes are minimal and isolated. And for last, it is professionalism because the output formatting and interaction feel more polished and user-friendly. So that's it for the first part of our code.
Next up is a structural analysis program, which is designed to perform some calculations using engineering formulas that will analyze the behavior of a material under certain loads. So there are four parts of this program. First of all, it will prompt the user to enter the parameters that is needed for the calculation, and it can be seen from line 4 to 14, line 29, and line 46. Next, it will calculate the stress, strain, deformation, etc., and that can be seen from line 16 to 33 and line 47. Second to the last will be the display of the output. It can be seen from line 35 to 43, 48 to 57, and 61 to 63. And finally, it will do a safety check if the material is suitable for various applications. And that will be all for the structural analysis program.
Next on our program picture is a concrete compression test. This test helps calculate properties like yield strength, strain, and modulus of elasticity based on the input values such as force, shape, and deformation. The program begins by asking you to select the shape of the concrete sample. It supports both rectangular and circular shapes. I'm choosing a rectangular block with a 150 millimeters of length, 150 millimeters of width, and 300 millimeters of height. The program then calculates the cross-sectional area. Next, we choose how we want to run the test. I'll input a force value, and the program will calculate the ultimate strength of the concrete. Here, we input the yield factor, which is typically 0.85 for concrete, and the deformation the sample experience under load. The program then calculates and displays the yield force, yield strength, strain, and modulus of elasticity. It also evaluates whether the result passes a minimum required strength of 17 megapascal, and in this case, the result is a pass.
So in line with the compression strength, we also have the what we call tensile or shear test. Tensile and shear test are both used to determine the strength of the materials, but They measure different types of stresses. For example, tensile test. It measures the ability of a material to withstand a pulling force, while shear test measures the ability of a material to withstand a force that causes it to slide or shear along a plane. Where, if naalala natin kanina, there are three options presented when we chose material testing, and here's the twist. When the user chose concrete, the compression test appeared, but if the user happens to choose steel or wood as their materials, tensile or shear test will be presented. So let's give it a try. So then let's input the length, the area, and also the apply force. And there you have it. We can see now the result of the data that we've input earlier. So how is this possible? First, if you notice, the program first asks the user for the material's length rather, its area and the force. And then first the code will calculate the stress from dividing the applied force with the material's area. And also, there is a dictionary in here named material properties where it stores the two materials strength, yield factor, and modulus. And that's it for tensile and shear test. Thank you.
Hey everyone, now let's move on to the material cost estimator. Ang purpose ng feature na ito ay to help users estimate the total cost ng mga building materials based on their volume and price per cubic meter. Users can select 6 materials which are concrete, steel, wood, along with eco-friendly alternatives natin like fly ash concrete, recycled steel, and engineered wood. The user needs to input a material. For example, 1, ang gusto natin is concrete. The user will input ang gusto niyang dimensions. For example, 10 sa length, 15 sa width, and 10 for the height. The program calculates the volume and the total cost. It also compares the selected material with its cheaper alternative. Na sa situation natin is fly ash concrete and suggested switching dahil mas makakatipid. At the end, the program provides a detailed cost breakdown and highlights any potential savings. Nandito yung cost per cubic meter ng selected and alternative material natin, yung volume, and the overall cost ng selected and alternative material. So this is the cost estimator, and thank you.
As QuantifyIt is equipped with a range of powerful and user-friendly functions, we believe users will find themselves naturally switching or particularly liking our program. By offering greater efficiency, accuracy, and convenience in handling tasks, QuantifyIt becomes more than just a tool. It becomes a smart companion for decision making and productivity. So that is all for our presentation. We look forward to seeing how QuantifyIt transforms the way people work. Thank you.